Solve the system. Solving the system means finding out what the x, y, and z are. What are their values? So if you found one x, you found them all. If you find one y, you found them all. If you found one z, you found them all. So it's three variables we're looking for. This is the method we're going to follow. We're going to do some row operations and make this a 0, this is 0, and this is 0. You see, why should that help? Because if these were not there, I would just have the z, and I would already have the answer for the z. And then this z, I give it to the equation up above. So I would put this value in here, and then I could find the y. And then once I have the y and the z, I could share it with the one above, put it here and here, and I could find the x. We call that back substitution. So what you do is you plan it out. Notice, I would like these to cancel out to become 0. So I could multiply one of them by a -1. But keep in mind that if you multiply one of them by -1, it has to be the whole row. Otherwise, we're changing the problem. So it's -1 times each one of these. And here's the result of the multiplication. This one, you just slide it over. Now you're going to add these two. -x plus x, 0. -3y plus y, -2y. -2z plus z, -z. -1 plus 2, 1. And notice this one is going to replace row 2 because that's where the first 0 is. We're going to put that row here so that this 0 can take this position. Now we're going to go for this 0 and then this 0. So notice how the original system has been changed because this is a new row 2. The other remain the same. So we need a 0 here. So I'm going to multiply this x by a -2, but I have to multiply the whole equation. So after I multiply it, this is what we get. Notice now I could just slide equation 1 over, or row 1 over, and then combine these. This will give you the 0, -y, -3z, and -2. This row is going to replace row 3. So this is the new row 3. So you put it here. You replace the one that was there. So notice how we're adding the zeros where we need them. Now we need a 0 right here. So if I could make this one look like a +2, I could add these two and end up with the 0 that I need. So I multiply by a -2 the whole row 3. And this is the product. Row 2, you just slide it over, and now they're going to be interacting column by column by column by column. 0 plus 0, 0. -2y plus 2y, 0. -z plus 6z, 5z. 1 plus 4, 5. This whole row is going to be our new row 3. So this row is going to be replaced with this one because it has the 2 zeros in the right place. So finally, after you make those replacements of row 2 and row 3 was replaced twice, notice. One for this 0 and one's for this. Once you have these 3 little zeros, looks like a staircase of zeros. Notice, you just have to worry about the z in the third row. So you could solve for it. So you solve for the z, just take this equation and work with it all by itself. You get a z equal 1. That 1, that z equal 1 is true for each z. All these z's are 1s. So now you push it up to the second row. So that z that I found, notice the z that I found, this is the second row. I'm going to replace it with a 1 since I already know it's the 1. So I replace it and I solve for the y. Get the y by itself. Finally, y equals -1. Now I know the y and the z, so you share these values with the top row. I could put the y here, the y equal -1 here, and I could put the z equal 1 here, which is what we're doing here. So we're going to replace the y and the z since we already know their values. Here they are. And now you could solve for the x by moving all the numbers over to the other side. Notice 2x equal 4, therefore x would have to equal 2. This is what we call the solution. Notice the x always goes first, and then the y, and then the z. This is the solution.